Hello, good evening, sir. In this video, I am going to cover about my CML assignment 2, which is upon the X-ray diffraction. So, let's begin. Like my objective here is the firstly is to solve and refine the crystal structure using Olex2 software for the given three datasets, like the three datasets you have provided, which were data 1, data 2, and data 3n. And secondly, I have to make a crystal packing diagram using Vesta. Then two softwares are used, like Olex2 and Vestas are used. And thirdly, I have to simulate powder XRD diffraction patterns, like the peaks of what they are telling. I have to note them about and analyze them. And fourthly, I have to make a report on about three tasks. So let's begin. For the data one sheet, like the .hkl file and .ins file of data one. So objective one, the crystal structure. The given structure is of hydrochlorothiazide, which is C10H6N3O4S2Cl, and this is the actual structure. And from the pattern, I have found this structure, which shows the blue ones are the nitrogen, the white ones are the hydrogen, green one is the chlorine, and the yellow ones are the sulfur, and red ones are the oxygen. So I have found that due to the double bond, the oxygen length was a little smaller than other bonds, and the R factor I have achieved here is 3.88%. But how I have done this is like I firstly imported the .hkl file from the data, and here the programs was selected as shell access, and the method was direct methods, and then on clicking the solve button, I got a structure, and then I joined and mapped the elements based on this structure, and that's why. And for the refining part, for the fine tuning, I have selected my cycles as 8 and peaks as 5, and ACTA was used. So these lattice parameters were formed, which is tabulated here. And for the objective 2, which is the crystal packing diagram, here three different views are drawn, three different views are shown. The first one is the B and C are perpendicular and in the plane of the screen, like the computer screen, they are in the same plane. So these three are the view. Like here, the A and C are have a obtuse angle instead of being a perpendicular, which shows here is it is 111.208 degree. And the third one, B and A are in the same plane of the screen. So these point group was obtained, like the group name was P21, and the the group name was P21, which is shown here also. The point group is 2. So number of polygons and atoms are also shown, means all the object outputs I have obtained are mentioned here. And for the powder diffraction pattern, I have just clicked on the utilities part, and there I have selected the powder diffraction button. And on calculating it, I have provided with this result, there are certain peaks, and in between some smaller peaks are also obtained. So these X-ray dispersion coefficients for lambda equals to 0.154432 was scaled here. So you can see it means all the different atoms are covered here. And for the data 2, it is a it is of riluzole plus malonic acid, which is C11H9N2O5F3S. So here also I have firstly imported the .hkl file, and for it I have selected the cycles as 8 and peaks as 6, and ACTA was used. So this part is the malonic acid, and this part is a riluzoic riluzole, means both are drawn independently. And for the refining part also, I have for the refining part also, I have done the same as per the part one. So like by adding hydrogen, by I firstly constructed a basic structure and then added hydrogen and then selected this button for a better R factor. Like the R factor here I have obtained is 3.70, and here also it is of showing like alpha equals to gamma but not equals to beta, means two angles are 90 degree and one is not. So the total volume of lattice is obtained as 1286.2. So the reference structure are which are used here are of Riluzole. So this also resembles the same, like this is the oxygen, red part is the oxygen, green part is the fluorine, which is also written here, and the blue part is the nitrogen. So this malonic acid, there is a hydrogen bond, like dotted line shows a bonding which is not permanent but is of temporary or non-direct, like they are not exactly together, but due to certain forces like hydrogen bonding etc, they are making a bond. So like for the objective 2 or the data 2, like the crystal packing diagram, the same, the three diagrams are shown, the three different views. Like this is the b and c perpendicular and in the plane of the screen, and here is making a angle of beta which is 105.996, and then there is title, and then its lattice space group is p21 by c, and the space group number is 14 and the setting number is 1, and total volume is obtained here. The data means the results I obtained are stated here for the on the Vesta software. Like the objective 2 was done on completely on Vesta software, and here the objective 3, which is powder diffraction pattern, and in this powder diffraction pattern the peaks are obtained. Like earlier there were two peaks and in between smaller peaks were there, and but here a certain increment in peak, and all others are smaller peaks. These small peaks denotes like the crystal is the given peak is of a crystal, that's why. And the extra the dispersion coefficients for lambda for the same lambda are obtained also here. So now let's moving on to the data 3n, which is the riluzole plus orthophosphoric acid. So firstly starting from the reference structure, like here oxygen is attached with carbon and carbon is attached with fluorine like CF3, and there is a benzene ring, and there is a sulfur and nitrogen attached with a carbon, and the carbon is also attached with a nitrogen, and here is the orthophosphoric acid like H3PO4. So here like there is a bonding, like the orthophosphoric acid and the riluzole are making a bond, like they are coming together, so that's why a bond a strong bond is building between them, and the structure the composition is C8H8N2O5F3PS, यानी कि so for the solving part I am taken as a shell access and direct methods, and rope.html file is used. So and for the refining I have firstly built a rough structure, like I firstly joined the carbons, and then I found that three all together were there, and like total five were there, like 3 and 2 5 were there, and so I have found that these three bond lengths were nearly same, so I have considered like these must be the fluorine, and this is the oxygen. That's why first one bond is there, and in between there is a carbon. So like this I was found at non-planar, like the sulfur and nitrogen were out of the plane of this benzene ring. So here the R factor I have obtained is a 3.32, and here also alpha equals to gamma but not equals to beta, which is 98.247, but alpha and gamma are 90 degrees. The volume of the crystal, the volume of the lattice here I have obtained is 1273.41. So for the crystal packing diagram, this is the B and C perpendicular to each other and in the plane of the screen. And here A is a obtuse angle, but in the plane of the screen with the C axis. And this one is the B and A are perpendicular in the plane of the axis and plane of the screen. So the title, the lattice type is P. The space group name here is also P21 by C. The space group number is 14. The setting number is 1. And these lattice parameters are shown. Yes. And the objective 3, which is the powder diffraction pattern. Here, multiple peaks uh, there are some moderate peaks also, like multiple moderate peaks, and there is a sharp peak at the beginning at nearly 6 degree. So this is plotted with 2 theta versus intensity. Like intensity is here, intensity maximum is at the beginning only. So the X-ray dispersion coefficients are also obtained and are stated here. So now moving throughout the analysis, what we obtained from the that powder diffraction pattern, what all they are saying, like the sharp red peaks in the diffraction pattern indicate that the compound is crystalline. Yes, the sharp peaks I have obtained all shows that it is crystalline. Otherwise, there will be a there will be a band instead of peak. So, the alignment between the red peaks and green sticks suggests that the sample is well matched to the reference structure, confirming the expected compound formation. The alignment with the red and green, these red and green aligns, which shows like the expected compound is formed accordingly. And the third one is the position relative intensities of peaks are indicative of unit cell symmetry and parameters. So these relative symmetries, these relative intensities show the unit cell symmetry and parameters. And the absence of extra peaks, other peaks, some diffused or the noise peaks, which are not here, means I have not considered it by taking a reference. So this shows that the sample is pure and does not contain significant impurities. And the term which I have stated from the very beginning, which is the R factor. So the R factor states that it is the residual factor, which measures the difference between the observed diffraction pattern, observed diffraction intensities, and those calculated from the crystal structure model. Which means it is nearly the error from observed data and the theoretical data. Like it is calculated as sigma f observed minus f sigma f calculated divided by sigma f observed. So lower values suggest a better fit. If the R is less than 5%, which I was managed to get in all the three data sets, like it was around 3.8 or something. So this shows means a better fit curve I have obtained. And for the R1, which shows based on the structure factor amplitudes. And also there was a term, if I show any diagram here, one is R1 and second one is WR2. That WR2 is the weighted R factor, which emphasizes weaker reflections. So, sir, now my assignment 2 is complete. So, thank you, sir. I hope you will be fine from my video. Thank you, sir.